of it is that databases, they offer different API to interact with the database. So luckily, we don't need to learn those APIs of each database. There are some much higher level of abstraction API that most platforms provide. Like in Java, the famous interface provided or API provided by Java to interact with any database, it's called JDBC. Now, to use JDBC, you need to use a driver, and that driver is specific to each database. So each database has its own database driver. And you as developer, you write your program using the JDBC API, and the driver translates your calls from standard calls to API calls that are specific to that particular database. And I explained this already. For example, JDBC, there is JDBC driver for Oracle, JDBC driver for DB2, JDBC driver for MySQL, and so on. And most of the time, the vendor provides such a driver. And there are some third-party, these days, most of them open source drivers. Okay. Now, in terms of programming API that is offered by JDBC, we have three major abstractions or three major classes. There's a connection class to connect to the database. Then from connection class, you can create a statement. And then from a statement, you can run a query. And then from the results of the query, you get back a result set. And then basically you process that result set. I think I showed you this, but let me just super quickly show it again. By the way, I moved everything to Eclipse now, so I'll be providing you all these examples. So let me just super quickly show you a simple example of what I mean. Okay. All right, here it is. Okay, so first you see here I load the driver. In my case, I'm using a very lightweight database. Most likely, before I give you this example, maybe I will switch to a much better database. Do you have any idea which database most of you might be using? You have anything in mind? Not yet? Because I think you need to make that decision soon, especially when you start doing the logical ER diagram, especially if you go the direction of using, let's say, visual paradigm, it will ask you to choose the database. Why do you need to choose the database as early as possible? Because of, sorry? Largely same, kind of. It's more the data types will be slightly different from one database to another. So if you are starting to use, let's say visual paradigm, if you have, let's say, first name, it will be, let's say, varchar 50. Maybe in Oracle, they may call it varchar 2 or some other, or a string. I'm not sure what will be the type. There are a lot of similarities, of course, but there are some slight differences. So you need to choose your database. Also, based on your choice, I might switch to that common choice, so it's more beneficial, the discussion I will have. But it doesn't really matter for what we're doing. The one I am using, as I explained, is a Derby database. You can look it up. It's an open source, very lightweight database. You can have it either as embedded or as which embedded means it will be part of your application. It's just a jar within your application, or it could run separate and you access it remotely. It can be even on a separate machine. So as I explained, the first step when you want to interact with the database, you load the driver. From where do you get the driver? From the web. Like depending on if you are using, let's say you will use SQL Server, you will have to look for JDBC driver for SQL Server. And you need to download the jars, and then you start using them. Now, this is using JDBC. I'm just giving you like an idea how it works, but in real life, you will not use JDBC. You will use something like JPA, which is slightly different. But still, JDBC is still there in the background, so it is important to understand what it is and how you use it. So as I explained, the first step is to load the driver. Second step is to create a database connection to the system. So in here, because in here I'm making it a little bit more complicated, you can have the choice either to use the embedded database or use the network version. It's up to you. But in your case, you will choose one and stick to it. So now how do I connect? All I do, I go to this class here. I go to this class called Driver Manager, and I'll say, please go ahead and give me a connection. And usually in the connection, I specify the host name where the database is running and the port. Because as I explained last time, database is typically running on a separate node on the network, listening to incoming requests on some ports. So for you to be able to access that particular database, you need to know the machine name. If it's on the same machine, you will put localhost and then the port. And typically, you need to specify what database you want to connect to. In a database server, you could have multiple databases running on that server or hosted and managed by that server. You need to specify that, and you need to specify username and password. Yeah? This will allow you to connect to that particular database. So this line here will give you back a connection object, and then using that connection object, you create a statement. And using that statement, you go ahead and execute a query. A query, this is nothing but an SQL query, which is a text string. You pass it as a parameter to execute query. And then once you execute the query, you get back a result set. A result set is a tabular data structure. It has rows and columns. And then you basically loop through it. And as I explained before, most of our programs these days are made up of classes. So for each row, you create an instance of the class. You create an object and put it in a list. So take a look at this. What I'm doing here, I get a result set, and I loop through each result set, extract the ID. In here, let's take a look at this. Select star from customer. I pick up the ID, which is an integer. I pick up the name. Using these two pieces of information, I construct an object, which is customer, and add it to the list of customers. Yes? Is clear what's going on here? So to summarize, I load the driver, make a connection to the database, create a statement, use the statement to execute an SQL statement against the database, get back a result set. Usually this result set is kind of not very friendly to manipulate. You have to convert it to objects, usually a list of objects, and then that's it. You are back to your own object-oriented programming world. Yes, it's clear? Now, if you want to insert, let me show you. If you want to insert, here it is, JDBC. If I want, let's say I want to insert, add. Can you see here, add? Can I increase the font? Okay, this may be better. Here is the add. So add, those of you coming from programming background, you will realize add is a method. It takes as an input an object. And this object, the data type of this object in our case is a customer. So my goal here, I have a customer object. And what I want to do with this object, insert it into the database. So the way to do it, I have to create an insert statement. But you can see here the insert statement is it's not very elegant way of doing it. I'm creating a string, insert into customer. This is the attribute I want to insert into. Values, and then concatenate the name coming from customer. And this will be insert into customer values, and then put the name coming from the customer object. And then once I construct this insert query, again, I connect to the database, create statement, and execute an update. Instead of execute query, this time I said execute update. And I'll say, go ahead, when I insert a customer, the database will automatically generate an ID. And then I'll get back that ID as a return of this execute update. Okay. And then what I do with that ID, I set that ID as an attribute of the object that I received as a parameter, and return everything back to the caller. Why am I returning back the customer object to the caller?
To say that we finished?
Not only that, but also to communicate the ID. Yeah, because the ID was auto-generated by the database. This is very, very common pattern developers do. Is clear? So what I did here, this is add method. It takes an object. I cannot just take that object and push it to the database. There is no way. I have to insert it. So which means I have to create an insert statement and submit the insert statement as a string and send it to the database as a command string to ask the database, please go ahead and insert this new record. So unfortunately here I have to create that insert manually by concatenating strings. That's how it is done. And for update is very, very similar. You can see here update is very similar. Somebody has an object, customer objects, and they ask me, please go ahead and reflect these changes I did, reflect them back to the database. Same thing. I have to create an update statement. Say, oh, update customer table, set the name to the name that's coming in this parameter, where the ID is the ID coming from this customer object. Yeah. So this will be update customer set name. Let's say set name Falah Ali, where ID equal 123. So that is the statement that gets created. Same thing again. I go ahead, get a database connection. From the connection, I get a statement. From a statement, I go ahead and execute an update. Give it the update string that I constructed on top here. And then once the update is done, I get the number of records affected. In this case, because if the ID is unique, I will get one record maximum will be updated. Yeah, or maybe it could be even 0 because somebody might have deleted that record by the time I was updating it. So this is just a way to confirm whether the update was successful or not. You can get back how many rows were affected. It's clear? Now, same thing for delete. Here is the delete. If somebody asks me, please go ahead and delete. Usually when we delete, they just tell us the key. Tell me the key, the ID of the record you want to delete, and I'll go ahead and delete it. You don't need to tell me the whole object. I just need the key. And then I construct a delete statements, delete from customer where ID equal the ID that you told me. Again, connect to the database, get a statement, and execute the update and get the rows affected. That's it. This is how I do it. Yeah? Yes.
The query is case sensitive? Or?
No, most of the language, no, not case sensitive. Yeah, most of they are not case sensitive. And most databases, even the names of the object attributes and methods by default are not case sensitive in most databases. Yeah. Luckily, they are not case sensitive. Otherwise, we have to be even more careful. Okay, that's a good question. All right. So, for example, for get, I already explained this, but I just show you again. For get, I will connect get statement. Instead of doing execute update, I will do execute a query. I get a result set. I look through it and convert it to a list of objects. Because in programming world, we mainly deal with an object-oriented style. We deal with objects. We don't deal with the tabular data structures. We have to convert between the two. Okay. If I have some kind of complex query, for example, here I am doing a summary. Remember you had a reports use cases? That's why I emphasize on reports. Because when you do reports, usually you're doing some kind of aggregation of the data. So in here, for example, I am getting for each customer, what is the total quantity they have ordered. So what I'm doing here, I'm taking customer, joining it with orders, where the customer ID equal to the order customer ID, and I'm grouping by name. So this way, for each name, I'll get what's the total quantity they have ordered. And this is a summary report. And you can see here, I put it as a string. Go ahead and execute it, get a result set back, loop through the result set, convert it to an object, and add it to a list. This is the common things how when we deal with JDBC, this is the programming style, how we do it. Yeah. So this programming style is kind of okay in a simple scenario where you have small number of attributes. It's not the end of the world if I just create a statement like this. Update table and set a couple of attributes. But in real world, that's not the schema of tables. You might have hundreds of columns. You don't want to be doing this. Okay, this is very fragile. And you have, for example, concatenating string with integers. You have to do casting and lots of little things you need to worry about. Plus, it's not very elegant at all. And the problem is that this problem is really known as impedance mismatch. This is the technical term people use. Impedance mismatch is basically means a conceptual mismatch. There's a conceptual mismatch between object-oriented programming and database world, between the programming world and between the database world. There's a gap. There's a gap between the two. Yeah? In the programming world, we mainly talk about objects. And in the database world, we talk about tables, rows, columns, and so on. Different. There is some similarity, but it's different. Yeah. Now, how is this gap addressed in traditional JDBC programming style? How is the gap between the object-oriented world and database world? How we bridge this gap if we use just plain JDBC?
By making each table as a class.
No. I mean in JDBC, like the way I showed you, we bridge the gap ourselves as developers. So for example, I have an object, which is really an object represents what? A row. No. An object usually an object represents a row in a table. And a list of objects usually represents a subset of a table or a result of a query, typically. Okay. Now, in this little scenario here, I have a customer object. And I need somehow to transform it into another database concept, which is a row. There is a gap between these two worlds. I wish if I just took the object and somehow push it as it is to the database, but that's not possible. There's a gap between the two worlds. How I am bridging that gap in this scenario here? By writing my query myself. I am writing the insert statement. And this insert statement is the bridge between the two worlds. But unfortunately, I have to do it myself. Every time this is update, I have to do insert. For add, I have to do insert. For update, I have to write the update statement myself. And for deleting, I have to delete. I have to do everything myself. Basically, translate changes or additions of objects into SQL statements. And that is very annoying, error prone, and there's no very not much excitement there. It's just very boring task to do. The most boring task you can assign some programmer is this task of converting an object and constructing some SQL statement to push to the database. Okay? And this is where people get so annoyed with this, and they invented this object relational mapping, where we don't want to handcraft those SQL statements ourselves. We just deal with objects and let some framework or some middleware or some library behind the scene generate the SQL for us. Yes, that's basically the idea. The idea of ORM is to bridge the gap between the two walls, to bridge this gap, this impedance mismatch or conceptual mismatch using ORM. So you can think of it as a way of, if I have objects, I can easily push them to the database. When I get records from the database, I get them as objects. I don't see them as records. It's not like in here in JDBC. Can you see here in JDBC? When I get the results from the database, what do I get back? Result set. And as I explained, what is a result set? Table is a tabular data structure with rows and columns. It's not very friendly to program with. Usually I need to unpack it into objects, and I have to do this myself. You see here, there's a loop here. You might say, oh, this loop is very easy to do. Well, imagine you have 100 columns. You have to do all of this, and you have to think, oh, if it's an int, you use get int. If it is a string, you use get string. And by the way, you need to be aware of the column names. And you need to be careful. If you make a mistake in the column name, when are you going to find out? At compile time or execution time? At execution time. Yeah. And if somebody for some reason changed the column names, then you have a problem, of course. And you won't find at design time, at programming time, at compile time. You have to wait until you release it to your users, and they will get annoyed with you because your program just crashed. Yeah. So all these problems are there when you do. That's what ORM tries to do. So here, the idea of ORM is that because I want to quickly go through it. The idea of ORM is all you need to do. You want to make it as simple as possible by going to your classes, adding some annotations to them, and then using some other API other than JDBC to push those objects to the database, and also when you get records from the database to auto-convert them to objects. That's what you really want to do at the end of the day. Okay, so the general solution is object relational mapping. This is a general solution. And an example of ORM, so ORM is general solution. An example implementation of this idea of ORM is JPA, Java Persistence API. This is in the world of Java. In the world of .NET, there's something called Entity Framework. In the world of JavaScript, there is, I think, Loopback, for example. In the world of Python, there is a framework, and so on. Okay, but the idea is the same. The idea is exactly the same, or at least similar. Okay, so JPA. If you look at JPA, this diagram here summarizes the whole idea. So what you do is you go to your entity classes, you annotate them. I show you shortly some examples, and then you use this is a major class in the JPA library. This class is called Entity Manager, and this Entity Manager is the one responsible of pushing your object to your database by generating the SQL behind the scene. So of course, in the background, there is still JDBC, there is still SQL going on, But who does it? The entity framework, not you. The ORM solution will do it on your behalf, not you as a developer. Okay? And of course, the entity manager will, at the end of the day, behind the scene, will be using JDBC, and JDBC will talk to your database. Okay? You can also use a query, and you can write a query, but this time you will be querying objects, and those queries will get translated to SQL. That's the basic idea of JPA. Okay, now with JPA, these are the tasks. These are the tasks for you to do as developer. You need to go to your classes and add some annotations. Okay, you need to use a new programming API. Most of the API is available through this important class called Entity Manager. You also need to create this persistence.xml file. This persistent.xml file, it provides all the configurations to connect to your database. Okay, so let me start with this persistence file just to show you how it looks like. So if I go here, there's a file called persistent.xml. Persistence.xml, where is it?
Sorry, which JPA framework will you be using now? Like it's the default one or Spring?
Sorry?
Which JPA framework you be using?
Okay, I will explain that shortly. So in Java Persistence API is a standard set of classes and interfaces. So anyway, it's a long story. Basically, Java, the way it works, every feature, let's say for JPA, is a standard. So people from different companies, they come together and they decide what are the name of classes, how many classes we will have, what are the methods in every class, and they make it as a standard, and they agree on this. And then they go back to their companies or maybe open source, and they go ahead and implement that standard. So JPA is a standard, which means the name of classes, the name of methods and attributes and so on is fixed. And then you will have many implementations of JPA. One implementation that I'm using here, it's called Eclipse Link. But there are many others. So if I go here and I go to JPA implementations, there are many JPA implementations. Batu JPA Eclipse Link, this is the one I'm using. Yeah. There is also ObjectDB, OpenJPA, and so many of them. Okay, but the Eclipse Link is quite popular because it was formerly maintained by Oracle, and sometimes they get sick of it, and it's becoming a trend. They maintain some library, and then suddenly they just give it away as open source, usually to Apache or some organization to take care of it. But this one is given to Eclipse. So Eclipse, the famous IDE, they are maintaining this implementation of JPA. Okay. So let me just show you what this file means. By the way, you don't need to go through because this is in itself, it's quite big. So what you do, what I recommend to do, you take I'll be giving you an example fully running. It's easier, I think, especially those of you don't have a lot of programming experience, is to change the ones I give you. It's easier. Okay. So in here, basically, the main thing you need to specify the entities you will be managing. Okay, and you need to specify what database are you working with. In this case, I'm working with Derby. It could be SQL Server, DB2, whatever database might be. And you will specify also the JDBC driver you will be using, the URL where your database is running, what is the name of the server, what is the port, what is the database name and so on, and also the username and password. So basically in this persistence.xml, it gives all the parameters needed to connect to your database. That's what this really does. Yeah. Okay. Now, so when you learn this JPA, what you really need to learn? Persistent XML is easy. You just take an example and modify it. You don't need to break your head. It's not that hard. And then the bulk of the effort of learning JPA will go into these two tasks. You need to learn the annotations, what annotations go into your classes, and you need to learn the API provided by this entity manager. So those are two skills you need to learn for you to be able to use JPA. Before I proceed further, what I want to highlight in terms of classes. So as I explained last time, a program in an object-oriented world is made up of classes, many classes. Now we can categorize these classes. One way to categorize it in three major categories when you are doing a realistic implementation, especially if you're using some kind of modern architecture of implementing your solution. So your classes will be categorized in three categories. There are entity classes, repository classes, and service classes. I'll explain every one of them, and I will show you each one of them how you will do it and the role of each one. Okay. Now, entity classes. What do you think? What are entity classes? Sorry. No, not actors, not really. What are entity classes? No, not field. No, what I mean is entity classes. The role of entity classes is just to hold some attributes. They don't have any functionality. They are mapped to tables. Okay. So these entity classes, they could be your actors, they could be the objects in your system. For example, some of you have, let's say, ride sharing. So a ride is an entity class. A ride, the ride itself. The driver is another class. Let's say passenger is another class. Car is a class. So those are entity classes. These are the ones that are the focus of JPA. Because these entity classes, what we will do with them, we will map them to tables in our database. So usually in these entity classes, we don't put any logic. We don't add lots of methods. Maybe just the attributes and get and set methods to read and write from attributes. Yes? Now, what about repository classes? Sorry? Yeah, these are the classes where I'll put my read and write methods to read and write from database. Yes, the repository is the classes that I use to interact with the database. Yes? What about service classes? No, those are add, delete, and so on. So service classes is basically usually exposing the whole application or the functionality of the application as a web API, where basically your application becomes accessible through the web. This is how modern applications are built. You have entities mapped to some kind of tables on your database. You have repository classes that read and write to your database. And you have service classes. What service classes do? They expose your application to the outside world. And your application becomes accessible through the web. This is where we stop. On top of this, you have the user interface that will interact with the web API. The user interface never ever should talk directly to your database or your repository. No, they should come to this web API. Why is that? If you follow this architecture, you basically can have multiple user interfaces accessing the same application. And this is becoming very common. So if you go, for example, QNB, they have a mobile app, they have a web app, and they have also the black screen app in the terminal app in the branch. If you go to Qatar Airways, for example, you have a web app, you have a mobile app. Those are just interfaces. They are not that important. Interfaces change and you can have multiple of them. But the good news is all of them, they use the same web API. Yeah. Interface is just for visualizing the results, giving some user experience for users, some user interface for users to interact with your application. But the heart of the application is implemented in repositories and classes that actually do the actual work, actual reading and writing from databases and so on. Yeah. I'll go through this in more details, but just to show you quickly, even in my, take a look at this. This is how I organize my solution. I have here JPA Entity. These are my entity classes. For example, here I have a customer, order, and order summary, 3 classes. And then I have here repositories. I have one for customer, one for order. And then I have services. I have one service, which is a customer service. I will explain what this means. So it's just a way of keeping my implementation organized. Okay, so it's clear the difference between the 3. So entities just holding data that I care about, and they are usually mapped to tables. Repositories to read and write from the data source, such as database. And services to expose my application functionality to the outside world. Now, the outside world could be another application, could be a user interface, either web or mobile or desktop application. It doesn't matter. Yeah, that's basically how modern applications are architected. So now JPA, what type of classes it focuses on? It first focuses on entities. So what we need to do with entities, we need to map them to, before we can store instances of those entities into our tables, we have to map. We have to tell the JPA, by the way, this entity, let's say customer, corresponds to the customer class. Employee entity corresponds to employee class. Order entity corresponds to the order class, and so on. How do I do this? How do I tell the system the mapping between entities, which are classes in my program, and tables which exist in my database, through what is known as annotation? I'll go ahead to my classes and add some annotations. So here is the minimal annotation that I put for me to do this mapping between the 2 worlds, the world of classes and the world of tables. All I do, I come to my entity class. On top of it, I add this annotation, at entity. That's it. What this at entity does, it maps it maps the entity class with, it maps the employee class with the employee table. Okay. But if I wish, I could put a little bit more details here. I can put here table name equal, and I can customize. I can put here, if you are coming from Oracle, if you put employee, they don't like it. They like to kind of shorten things, which is completely different than Microsoft people. They like to put things explicit. Anyway, so to keep the DBA happy, you might change the table name. No problem, you can do that if you wish. So, but this is the minimal. The minimal in this course, at least, because this is not our main focus, but at the same time, I want you to really see how the database is integrated with the application. Yeah. So for the purpose of our course, just add this annotation is more than enough. In fact, for me, I like it when the name of the class is the same name as the table. Why not? It's even better. Okay. But if you wish, you can customize the name, no problem. Now, what about this annotation here at ID? What is it doing? It's indicating that this is the primary key. That's it. These are the two minimal annotations you do. If you just add these two annotations, خلاص, your class is now mapped to the table, and this entity knows which attribute is the primary key. Is clear? Now the good news, once you do this, no longer you need to write SQL statement to read and write from database. Now let me show you, just to complete the picture.
There was no, let's say we have a validation table that doesn't have a primary key, like, or a table that doesn't require a primary key from the database. So we have to specify
I don't. It's not necessary. Basically, I think it's not required 100%. But in 1995, 99% of cases, every table has a primary key. In most cases, yeah. Even lookup tables or reference tables still have a primary key. Yeah. So it's very common. It's very common. So in here, we'll just focus on the common things. So now, where do you think the code, the methods to read and write to the database, in which type of classes you will find these methods? In the repository, yes? Not in the entities. Look at the entity. I'll just show you here. This is my entity here. The entity basically has nothing, only the attributes. It doesn't have any logic. And in here, let me just show you here. This is for other stuff. Don't worry about this annotation. This is the annotation for JPA. And here I am saying this is my ID. And by the way, this ID is auto-generated using this identity. Depending on the database, you can use identity. There are other strategies. I think sequence or something like this. Sequence and so on. But other than that, okay. You can also annotate the relationships to other entities, which I will discuss later. But for now, I just want to focus on the simple possible annotation, which is entity and ID. And then once I do this, if I go to my customer repository, take a look at this. There is something called Entity Manager that I create using something called create Entity Manager factory, and then from factory, I create the Entity Manager. Don't worry about these two lines, just copy paste them. All they do is they create an Entity Manager. This Entity Manager is the most important class in JPA. The most important class in the whole framework is called the Entity Manager. Now, what is this string here? What do you think? Create an Entity Manager factory, and I put here Derby Customer DB Persistence Unit. This one refers to all this configuration I showed you. Remember this configuration? I showed you this configuration file. Here it is. Come on. Yep. You see this configuration file? Because in my application, I might have multiple databases. Each one has its own configuration. So this configuration, I gave it a name, and I can use this name when I want to create an entity manager. Okay, but for now, that's not very important. Now, if I want, once I create this entity manager, if I want to query and get, let's say I want to get a customer by ID, I don't need to create select star from customer where customer ID equal the ID passed as a parameter. All I do, I'll go to the entity manager and say, please find me a customer with this ID. That's it. Magically, it will go ahead, query the database, get the record, and convert it to an object and return it in one line. I don't need to do that, connect to database, create statement, execute the statement, get a result set, go through the result set and all that stuff. In here, I just get an object back. That's it. If I want to add, all I do, entity manager, this is an object I want to add. I'll say entity manager.persist, and I give it the object. It goes ahead and persists it. Yeah, that's all. If I want to update, same thing. Entity manager.merge. Take this object here and merge it with the record I have in the table. For deleting, same thing. For delete, many ways of doing it, but one way is I'm creating here a query and deleting. Now, this query here is not really a query. It's not really SQL. It looks like SQL, but this is using manipulating the objects. What I mean here, if I put here customers, this problem will be picked up at compile time, because this is not really querying. This is not querying the table. This is kind of querying the objects I have in my implementation. So if I have some mistake, they can be detected at compile time. Yeah. Okay. All right. What else is there? Now, if I want, let's say, take a look at this one. It's a very interesting one. So what I'm doing here, I go to the entity manager and say, please go and create for me a query. This is the query I want to do. And then I'll say, get the result list. And then guess what? What this will do, this will give me back a list of objects. Not a result set that, you remember in JDBC, I get a tabular result set and I have to look through it myself to construct the object. In here, it is automatically done for you. After the query, you will basically get back a list of objects. Is kind of clear the idea here? So to summarize, I go to my entity classes, annotate them to map the entities to tables, and then I start using the entity manager to interact with the database. That's all. That's the major idea. So in terms of annotations that you must know or you must be familiar with, you have this annotation here at entity, and you have this annotation here at ID. Okay. Anything beyond this is more, of course, more details. For example, there is another one here. If your ID is auto-generated, you can say so by adding this other annotation called generate. This is a generated value. This is this ID generated using this technique identity. In most cases, most databases support this technique identity. Okay. The other one, if you wish, you could start customizing things if you wish. All what I'm saying in this slide are optional. If you don't, by default, if you just stop here, if you don't put this part, your table will be named same name as the object. Okay. If by default you don't need to put anything on the columns. Your column names will be the same as your attribute names, which is a good thing to do. Unless if you want to take on yourself extra headache and customizing the columns. You can if you wish. You see here I'm customizing the column. Yeah. And I'm putting even here, the reason why I am putting all this stuff, because guess what? From the entities I'm putting effort in annotating, I can generate the database from the entities. I don't create the database from scratch. That's another thing to do. So I can put efforts in my class diagram, generate entities, annotate them, and then run my program, and my database gets auto-generated. Now, if I want to customize how the columns behave, whether they are null, what's the length, and so on, I can do this through annotation. Yeah. So, in fact, after I run this program, another 5 minutes, I'll stop. After I run this program, there is, let me see, window. Yep. Okay, see these tables here that you see here in this database. This whole database and this whole table was generated from the code. I did not create this database myself. In fact, in testing, whenever you run the program, the database gets dropped completely and then recreated again from scratch. So this is the power of some ORM like JPA. You invest the effort in your classes, designing your classes, annotating them, and you can easily generate the database. And vice versa, you can do the other way around. If you already have a database, you can use a tool like Visual Paradigm as an example and generate the classes from your database. Yeah, that's basically the idea. Yes, please.
So some people use something else called Hibernate.
Yes. So JPA, before people come to this JPA as a standard way of doing this persistence and saving and retrieving data to the database, there were many, many efforts. It took a lot of effort and time and years of development to reach to this level of maturity. So Hibernate is kind of was there much before JPA. So JPA, so the way it works usually in Java world, there will be some initiatives, different initiatives from different open source and maybe sometimes even commercial efforts. And then they get together and try to standardize it. Because everybody is doing it slightly different way, they standardize it. And this standard way currently is JPA. Now maybe Hibernate came again and implemented this standard. So if you remember this one here, say maybe you can think of, I haven't verified this, maybe you can put here Hibernate as one implementation of JPA. Okay, it's just another implementation. But in terms of learning and in terms of API, you learn it once. What you need to learn when you want to use the JPA, you learn the annotations and you learn the API of the Entity Manager. Those are the two skills. Okay, and in terms of implementation, you can choose any implementation: Eclipse, Link, Hibernate, other implementations as you wish. Yeah, that's the power of standardization. You only learn one API, and you don't need to learn many implementations. You have the choice to switch between the implementation that suits you best. Okay. Okay, I will stop it here. Okay, here it is, another one here. This is just another example. Another final example in terms of simple annotations. I have here a customer entity mapped to the customer table. The way I do the mapping, all I do is add this annotation here at entity. Now, this is the primary key of this table. This is the primary key. I say so to the entity by adding this annotation at ID. By default, the name of the attributes become the name of the column. But if you wish to change, no problem, you add further annotation. For example, here, this is credit rating. In the table, it becomes credit. If you wish, you could do that. But for me, like the best approach is to have good naming conventions, clear names, meaningful names, and just use minimal annotation. You only customize if you really, really need to. So I will stop here. When we come back, I want to show you how we annotate relationships between entities. Remember in our ER diagram, we have entities have relationships. They could be one-to-many, one-to-one, and so on. How do we annotate this in our entities? That's what I will be discussing, inshallah, when we get back. Okay, thank you. So next step, I want to show you how we can annotate entity relationships. Remember, entities can have relationships, and these relationships could have multiplicity or cardinality associated with them. And the most common ones, one-to-many, many-to-one, or one-to-one relationship. So the way we do it, here is an example. We have a customer, and we have an order. And these two tables are linked with, or have a one-to-many relationship. So this is the one side table, and this is the many side table. Okay. So what we can do is we come to the one side table. This is the one side, and this is the many side. We come to the one side and say, by the way, this customer entity has a one-to-many relationship with orders, which means basically a customer has one or many orders. And by the way, how do we link these two is by using this foreign key here, customer ID. Remember when we establish a one-to-many relationship, we take the primary key of the one side and we copy it as a foreign key in the many side table. That's how we establish a one-to-many relationship. So this is exactly what we do here in the annotation. We say there is a one-to-many relationship between customer and order, and the foreign key to establish this relationship is the customer ID. Yeah. So basically, I do here one-to-many mapped by customer, and this customer here, this string here, is the name of the attribute. Now, if I come from the other side, from the many side table, if I'm looking at from order to customer, it is a many to one relationship. So basically, I go ahead and do annotation on both sides. This is, of course, if I want to do a bidirectional relationship. Bidirectional means from customer, I can get to orders, and from order, I can get to the customer. So this is a bidirectional relationship. So the way I establish it, I come to the list of orders because in C, like in programming in general, in Java, for example, when we have a one-to-many, that one-to-many is represented as a list. So so this means that the customer has a list of orders. So I come to this attribute orders, and on top of it, I put the annotation. And this annotation reads like this. Customer has one or many orders, and the foreign key that enables this relationship is this customer here. So I add this mapped by, and what I put here then in this string, the name of the attribute on the other side of the relationship.
Yeah, the name of the attribute or the name of
The name of the attributes, because remember, not the name of the column. Yeah. Because remember, annotation is referring to attributes of the class, not attributes of the table. Yes? So attributes of the table in here, if I am putting here the column name, let me see. Yes, customer ID. Yes. So in this one you see here is the attribute name of the class. Yeah, not the attributes in the table, the attributes of the class. So I put two annotations, one-to-many at the customer side and many-to-one at the order side. So let me just confirm this. I'll show you this concretely here. So if I go here, customer, if you take close look, here is my customer entity. And you saw here, I go to my order list or collection, and I added this annotation here, one-to-many. And the join column is customer ID. Interesting. Yep. And in the order, what did I do in the order? In the order, I want the customer attributes. Customer attributes. This one, in this case, I didn't do bidirectional. In this scenario, I did not do bidirectional. I just did one direction, which means from Did I do bidirectional? So sorry, is this bidirectional? No. No, it's only one direction. I didn't put any annotation on the other side. If I don't put any annotation in the other side, means from order, I cannot get to the customer. So you see here, the order does not have an attribute customer. I mean, when I say customer, the whole customer object. Bidirectional means, when I say bidirectional, the customer class has an association with the list of order class. Okay, and here in the order class, I have an attribute of type customer. This is a bidirectional relationship. In this scenario, in this example I have here in the implementation, it is unidirectional. In the customer, I am linking. In the customer, I am linking back to the order, but in the order, I am not doing a link with the customer. Okay, because I don't have in the order. If you look here, come on. I think I might need to close and reopen this. Yep. If you take a look here in the order here, I don't have. If I wish to do it bidirectional, I would do something like this. Many to one. This will make it bidirectional. But in here, it's interesting. The join column is customer ID. That's another way of doing it. So join column, and in here, sorry, I need to restart this one. I will restart it and show you.
But Doctor, no meaning to make annotation in one direction only, right?
No, it could be meaningful. What I mean is when there is, this is very common in object-oriented modeling and programming, when there is an association between two entities, between two classes, it does not need to be bidirectional. For example, let's say you have a customer has an address. So you will have, in the customer class, you will have an address attribute, and the data type of address will be address class, yes? Now in the address class, no need to have a list of customers that are living in that address or using that address. So it will be one direction. So from customer, you can get to the address. But if you have an address object, you cannot know who are the customers in that address. Okay, so when we have an association, it's up to us as developers whether to make it bidirectional or to make it unidirectional. It's up to us. I'll just close, don't save. Okay, exit. Okay, so I'll start it again, Eclipse. Okay, so this is how I do it. So this is the rules if I want to do it bidirectional. I go to the many side table, in the many side entity. So the many side is the one that is having the foreign key. The many side is the one having the foreign key. For example, in here, this is the many side, and this is the one side. Okay. So I'll go to the many side table and define the mapping to the database using the join column. So in the in the many side table, I need to specify the join column. One of the annotations must be the join column. On the one side, I put many to one. On the one side, the annotation will be many to one. And In this annotation, I also add this attribute mapped by, and in this mapped by, I put basically the, the name of the attributes on the other side, not the name of the column, the name of the class attributes. Yes.
Which is the foreign key.
Not the name of the attribute. Let's take a look at this. For example, for customer, what is the name of the attribute, the foreign key? Sorry, what is the name of the foreign key column? Customer ID. Yes. I don't put here mapped by, I put customer ID. I don't do that. In mapped by, what do I put? I put the name of the attribute that has the many-to-one annotation. So basically, this annotation one-to-many is linked to the other annotation many-to-one. So basically, I'm mapping this one-to-many with this many-to-one. And this mapped by must be the name of the attribute. Just be aware of this. It's not the name of the column. That's all there is. That's all there is to it. Okay. Now in the many side table, I need to provide the name of the column. So in the many side table, I put the name of the column, but in the one side entity, I don't put the name of the column because I already specified it in the many to one side. So let me say it another way. So in a bidirectional one to many, I have to have two annotations. Yes. So first I go to the many side table, sorry, the many side entity, and I add the annotation many to one. That's what I did here, yes? This is what I did. This is the annotation many to one. And plus I add the join column and I name it. In this case, what is join column? Customer ID. This is on the many side. This is what I do on the many side. Now, on the one side, what annotation do I put? One to many, mapped by, equals the name of what? The name of the attributes. The name of the attribute, this one, the name of the attribute that has the annotation, the many to one annotation. You don't always need to make it bidirectional if you don't wish to. You can make it unidirectional. And this is an example here. So customer and orders. So all I do one to many. One customer have many orders. And in here, I specify the join column. This is if I want to make it one to many, one side, one direction, which means in the order, I'm not having the customer. In the order entity, I don't have the customer table, yes? Sorry, I don't have the customer object. So a relationship could be that in object-oriented programming, an association between two classes could be unidirectional or bidirectional. So based on that, in bidirectional, there is there is a particular way of doing the annotation. In one direction, in unidirectional, there is another way of doing it. Okay, so let me summarize it. In bidirectional, how do we do it? Go to the many side entity and put many to one, and then specify the name of the join column. Yes. Then go to the one side and put one to many mapped by and specify the name of the attribute that has the many to one annotation. Yes? Now, if you want to make it unidirectional, then you do one to many join column and you specify the name of the column. That's it. Unidirectional. Yes, unidirectional means from the customer I can get the orders, but from orders I don't need to get the customers. Okay, which makes sense. In many cases, we always know the customer, so we first get the customer and get the orders of that customer. But very rare we get the order without the customer. Okay. Now, what I can also do, this is very, very important. Once I put this the reason why I'm putting all these annotations is that when I query and get the customer, all the orders for that customer will also be retrieved. Yes? That's why I put the annotation. Whenever I get, you see here, here's my customer repository. Here it is. This is my customer repository. Now, when I do something like this, find customer and customer ID. Because of the annotation, I put in the customer class, I put an annotation saying one-to-many relationship. Once I get the customer, the orders will be automatically also retrieved. Now, you can control when to get those orders by adding further annotation. You can see here, it is a one-to-many relationship, and here you want to do fetch eager or fetch. The other one is fetch lazy. Fetch eager means once I get the order, once I get the customer, I get the orders as well. When I read the customer, I read also the orders. Lazy means don't get the orders, only they get the customer, and only if somebody comes and tries to access the orders, then go and get them. Are you following? So for performance reasons, you might not need to get all the orders for a customer. You wait until you need them. So there are two strategies to read and write. Okay. Okay, the other one is, yes. What if I have a customer and orders? Yes. What if I have a customer and orders? Now, if I delete the customer, what should happen to the orders? You decide here whether to cascade and propagate the change, or you want to just stop it at the order. Cascade the change or not cascade the change. Anyway, those are details. Just be aware of them, especially for your project. You don't need to get into a lot of these very fine-grained annotations. As long as you do the basic annotations with the one-to-many, many-to-one relationship, this is more than enough. We're not trying to make it like very optimal in terms of performance. You can just leave the default behave. You don't need to change those default behaves. Okay. Okay, let me just move on here. Okay, I want now, these are the basic annotations you need to be aware of. Just add in entity annotation, ID annotation, one-to-many, many-to-one. Those are the main ones, more than enough for the purpose of the project. Of course, there are more annotations. You don't need to really go through them. Okay, now once you annotate, now you are ready to read and write to your database. To do so, you need to be familiar with the programming API that comes with JPA. Most of the API are associated with this class called Entity Manager. As I showed you before, this Entity Manager provides you this very important methods to read and write your entities from your database. To retrieve an entity, you just use the find method. To push a new entity, like insert, you use persist. Update, you use merge, and to delete, you use remove. Okay, so very simple methods that you use with the Entity Manager. Okay, those are the methods. Let me show you. So with find, I already showed you, with find, you do Entity Manager.find, the name of the class and the parameter. And when you are doing find, you are finding by the primary key. So the parameter must be the primary key of the entity. The attribute that has the @id. Remember, we have entity and @id. So find only works with the primary key. You can retrieve an entity using the primary key. Okay, for persist, all you do, you create a normal object, and then you go entity manager.persist. That's it. That's all you do. Now, we typically return the customer Why are we returning it? They ask us to persist it, and we did that, and we're returning it again to know the ID. It will be auto-assigned. When you do persist, it will be auto-assigned to the customer. So whoever, the caller of this add customer, they can get the ID if they wish. There is a remove. Many ways you can do it with remove. You can first get a reference. You don't need to get the full customer, you just get a reference. So instead of doing find, you can of course do find, but find will retrieve for you the whole object. And here you can just retrieve a reference to the object and then remove. That's one way of doing it. The other way of doing it is you create a query similar to SQL, where you say delete from customer, where customer ID is kind of a parameter here. This is how you create parameters in this is not SQL, this is something called GPQL. GPQL. It's Java Persistence Query Language. It looks very, very similar to SQL, but not really SQL. So delete from customer, where customer ID equal colon customer ID. Colon in front of the variable means this is a parameter. So you set the parameter and then you execute the update. So you can do it either way. Either get a reference, then remove, or run a delete query. So for update, you do merge. That's the equivalent. So you just take an object, you say entity manager.merge, and it will merge it.
By the ID?
In here, yes, like it will match. So all merge means the attribute that changed will be included in the update. By the way, the entity manager, what it's doing, it's also tracking the changes of your entity, of your entities. So it knows what changes the entity, what is the original copy and what are the changes. So it keeps track. The entity manager keeps track of the changes. And then when you say merge, what really merge does, it will take the attribute that has changed and create an update statement for them. So we'll say, for example, update customer, set first name equal the new first name, set address equal the new address, and so on. And then it will push it to the database. Yes?
What if I want to find what joining?
Yes, come in, yes. You need to write a query. But in this case, it's not. You can write an SQL query, I will show you shortly, or you can write GPQL query, and I'll explain the difference shortly. Okay? But those are the basic methods that we use: find, persist, merge, and remove. Those are the main ones we use. Now, just be aware, the entity manager, it might not push the changes immediately to the database. It can buffer them until later on when it decides so, and it can push them later. Okay, so kind of in a lazy way. It's doing everything in memory, and at a certain stage it will push them. So if you want to force the change immediately, you can do entity manager.flash, and this will push the changes that the entity manager has been kind of buffering, push them to the database. Okay. Okay, answering your query, if find is not enough, in most cases, of course, it's not enough, because find will only allow you to search by the primary key. You can also use the normal SQL, and I'll show you how it looks, or you can use GPQL, which is similar to SQL. What is the difference between the two?
Using the object classes.
Yes, you are querying basically objects, and when you are referring to the columns, you are referring to attributes defined in the class. In SQL, when you are writing SQL, you are referring to the columns of the table. This is a big difference between the two. It will look very, very similar, especially if you have kept the name of the classes, the name of the attributes, same as the name of the same as the name of the table, and same as the attributes same name as the columns, and the entities same name as the class. sorry, the entity same name as the table, then they will look very similar. Okay, but I will explain further the difference between the two. Okay, so the entity manager has three methods for you to create a query. There is a create a named query, create a query, and create native query. What's this create native query means?
From scratch.
No, native query means this is SQL, back to SQL. If this GPQ will give you hard time sometimes and it's better you want to just write it in SQL, no problem, you can write it in SQL. Okay, and then you can get the entity manager to run it for you. In this case, which method should you use? Create native query, and you can run it that way. Yeah, but in all cases, whatever method you use, the good news is the result will be a list of objects, not a result set. Yeah, whatever method you use, the result you will get will be converted to a list of objects, ready for you to use as a developer. Okay, create query, you create a query, but this time this query string will be referring to classes and attributes of the class, not tables and columns of the tables. And named query is a query that you create and you give it a name and then you can call it. So let me start with the name query and show you how they look like. Here it is. So for the named query, typically I'll go to the entity. On top of it, I can create as many named queries as I wish. So here is a named query here. I say, this is the name of my query, customer.getOrderSummary. And then in here, what I'm doing, it looks like SQL, but not really SQL. I am selecting the name plus the sum of the quantity. Joining customer with orders. Yes, joining customer with orders and grouping by name. So basically, this is a summary that will give you, for each customer, what is the total quantity ordered. But notice here, this is an entity class, and this one is an attribute of that entity. Can you see it? It's a little bit misleading. It might look like SQL, but it's not really. Because this, in SQL, it will look something like this. Join orders. Oh, something like this. But in here, I'm not doing that. I'm joining the customer entity with the orders attribute of that entity. And grouping by the customer name. Yeah? And then for each row that will be returned, I'll create an order summary for each of the rows. So once I get back the results, I will get back a list of what? List of objects of type. What is the type of the objects I will get? Order summary. Okay. An order summary, of course, is a class. Let me show you. Here is the order summary. It's just a class, normal class that has a name and total quantity, two attributes. So that's how it looks like. Yeah, that's what GPQL really looks like. I have here another query. Take a look at it. This one gets you the summary for all customers, and this one gives you a summary of orders per customer. So it looks exactly the same, except in here I have an extra where clause with a parameter. Can you see it? An extra where clause with parameter. So those are named queries. I create them and name them. The good news is, if I do some mistake here, okay, when I compile, I get an error. Although it is a string, it will be detected because this one is a class and I can verify. But if it is SQL, the compiler will not be able to help you because you are referring to something outside the control of the compiler. That's another advantage of doing the GPQL. Okay, now once I define these named queries, let me show you how I call them. how do I execute them? So if I go to my repository and I go to my get summary, get order summary. You remember get order summary as a named query? All I do, I go to Entity Manager, create a named query, and I give it the name of the query that I already defined before. And I'll go ahead and say, get me the result list. That's it. And what this will return me? A list of order summary. This is the power of JPA. I don't need to get a result set and look through and then extract the values of the columns and construct objects myself. I just get back objects. Now, in the other version where I have the customer ID as a parameter, I can do so as well. What I'm doing here, I create a named query, and then once I create this named query, I am basically giving it passing the parameter as the name of the query, setting the parameter expected by the query by saying query.setParameter. This is the name of the parameter, this is the value. And then I go ahead and say, go ahead and do get single result. In this case, because it's one customer, I will get a single result. And I'm casting that single result to an order summary. Yeah. Now, if my query happens to be SQL, all I do, create native query. And then here we will be an SQL statement, select from whatever. And then I'll go back and say get result list. And this will give me the list. Okay. That's basically the idea. Now for normal queries, here are normal queries. Here is, for example, a query, delete. This is, again, GPQL, not SQL. Let me see if I can see some other one. This is another one here. Can you see? If I want to get all the customers, all I do, select C from, see here, it's showing up now that it's not SQL. If it was SQL, what I will put here? Star. Select star from customer as C. But in here I'm putting just C because this is GPQL. It's a slightly different syntax. And sorry? No. C, this is the alias. Remember in SQL we have aliases of the, so a kind of renaming the entity. So I don't need to repeat myself when I'm referring to that entity. Yeah, it's kind of giving it a shortcut, so I can refer to that shortcut whenever I want to refer to the entity. I can use the shortcut to refer to the entity.
But you see that's after this select.
It's referring to this shortcut. So if this one was A, this one will also be A. Yes? So I'm saying this is the equivalent of select star. Okay, and then this is the query I am running, and then I'll say get result list, and I will get the list of, in this case, the list of customers directly. That's the advantage of using GPQL or using JPA in general. Okay, so back to here. So JPA queries, they could be named queries, dynamic queries that I write within my program, or native queries. These are SQL queries. And I showed you some examples already. Dynamic query, this query that I write on the fly here, it's not named, and I think the verification of the verification of the queries, I think, only happens for the named queries. I don't think it happens for these dynamic queries. Okay. And as I explained, I can have parameters in my query, set the parameter, and then go ahead and execute. In this case, because I'm expecting a single result, I can get single results. Otherwise, I do get result list. Native query. This is how the native query looks like. Take a look at this. So in here, I'm saying create native query, select star. This is SQL. Yeah. From users where username equals, this is a parameter. And here, this is important. I'm telling JPA, when you get back the results as a result set, as a tabular data structure, I want you to look through everything and return me a list of users. So I need to specify the class that I want to return. And then that's it. Once I do this, of course I set the parameter and then I'll do get single results. And that's it. What I get back? An object. So regardless of which type of query, at the end of the day, you use the same API and you get back objects. Whether you're using SQL if you want to use it, or you use GPQL, at the end, same API, same fact that you get an object at the end. Okay, so GPQL is similar to SQL. You have basically joins, group by, subqueries. You have all these capabilities at your hand. So I just go through super quickly just to give you some glimpse of what query capabilities we have here. So this is a basic select statement. You put the alias and you do select. Instead of select star, you put the name of the alias in here. If you want to eliminate duplicates, you can put the distinct. This will give you distinct players without repetition. It will remove repetitions. You can also have an aggregate query. This query here gives you the average. It goes through all employees having a salary greater than 80,000 and give you the average of those group of employees. Okay, I already showed you this. If you want to have parameter, you just precede the name of the parameter with colon, and then you can set the parameter and get the result list. You can do bulk updates. Bulk update means you update multiple records using one statement. Multiple records using one statement. So in here, what I'm doing here, I am updating the employee, setting the manager of every employee, setting the manager for particular department. So what I'm doing here, setting the manager for particular department. So I'm setting, let's say, set parameter. The first parameter here will be set to this variable here, and this second parameter will be assigned this value here. And then I'll go ahead and do execute update. This will do bulk update. Multiple records will be updated with using one statement. Same thing here, delete. I'm deleting a project that don't have any employees assigned to it. So delete from project where P employees is empty. Of course, in SQL, we don't have this empty. This is GPQL extension. And then I'll go ahead and see execute update. So these are the reasons why GPQL, the advantages of using GPQL. So in here, once you define the mapping, you don't need to deal with database anymore. You can just do the queries based on the schema that you have in your classes. If you have some annoying DBA and they force you to do some naming that you don't like, you don't need to fall into their naming. You can stick to your names that you have nicely named in your classes. And your queries will use the attribute names in your class. How they will name them in the database, you don't really care. You do that once in the mapping, and that's it. That's one advantage, especially if you have some contention between DBA and developers, then no problem. They can live on their own world with their own naming convention, and we can live on our own world with our own naming convention, and everybody is happy. Okay, named queries are checked at compile time for any errors. Yes, this is only for named queries. And the GPQL is more portable. This is very important. If you have an application, if you build an application, and that application you can, for the customers, they can use any backend database. This is very common, by the way. You might have, let's say, Banner, just as a theoretical example. You might have Banner, but you choose any database you want. You can choose MySQL or Oracle or DB2 or whatever database. Same application can work with multiple databases. If you have such scenario, it's better for you to stick to GPQL. Why?
It's a standard.
It's standard. And then those little differences between the databases will not affect you. Okay? Who will take care of these differences? The entity manager. And the entity manager, it's like there is also a driver that associated with the entity manager, which will take care of those differences for you. Okay, it's more likely to be portable than SQL. Although SQL, most of it is standardized, but as I explained before, every vendor tries to add their own spices and they break the standard. And the good thing also is that you can fall back to SQL if you have some query that is annoying or complex to write in GPQL, you can always write it in SQL, come back and use get or create. Is it called create? Create native query? Yes, create native query. And then you can run your normal SQL statement, no problem. Okay. All right, so last thing, and I hope you also try to do it in your project as much as you can, especially if it's relevant. I can see it is relevant for many of the projects I have seen so far. Is in object-oriented programming, we're doing inheritance is something very normal. In database is very weird, not very common in the mental set of database designers. But in object-oriented programming, we do this all the time, inheritance. Whenever we find ourselves copy-pasting and duplicating some piece of code, we don't do that. Take the common code, put it in one class, and then inherit it in other classes, and the other subclasses can extend or override some of the behavior of the superclass. It's very, very common. Now, the question is, how do we go ahead and map this inheritance to tables? Because in relational database engine, there is no concept of inheritance whatsoever. There is inheritance in the model. Remember, we discussed it last time, but not in the relational database. In the relational database, there is no such thing as inheritance. Okay, so now let's take an example here. Let's take an example. We have an employee, our superclass, that has all the common attributes. These are the common attributes, and these are the specific ones. For the part-time employee, they have an hourly rate, and full-time employee, they have a salary and an office number. These are the two extensions or two specific attributes. So to map this hierarchy into tables, we have three strategies. We need to be familiar with them, and we need to know the advantages and disadvantages of each of them. So the first strategy is a single table. What this strategy means? I can map this hierarchy to one table. What does that mean? All the attributes will be in one table. In the database, I will create one table and only one. And what will be the columns in that table? All the columns. The columns of the superclass and the columns of the subclasses. So it will have IDs, name, start date, hourly rate, salary, and office number. What's the problem here? It's not normalized. It's not very normalized, and you will have a lot of columns with null. Of course, this is a simple hierarchy. It's not a problem, because few columns is fine. But if it's not, if it's a big hierarchy with lots of distinct columns, then you will have lots of nulls. So for example, for part-time employees, these two columns will be null. And for full-time employees, that column will be null. Not bad if you have such simple hierarchy. Joins.
So if there's many subclasses, it will be many classes. But there's many subclasses,
Yeah.
there will be many nulls.
Yes, many columns that are null. And plus, you might end up with not so normalized table. Normalization is lower. Okay, now joint strategy. What joint strategy will do?
Join the tables, the sub.
So how many tables we might end up with if we go with joint strategy? 3. Okay. So 1 for the superclass and another 2 for the subclasses. So the data will be spread into 2 tables. The common data will be in employee, and the specific will be in, for part-time employee, you look for specific one. Okay? And for full-time employee, you do join with the employee. So what is the problem with what is the advantage of this? Normalized, no duplication, no nulls, and so on. A really normalized design. What's the price? Performance in what sense? When you read, you have to join. Join is expensive operation. And when you write, you insert into 2 tables. You insert the common things in the superclass table, and you insert the specific things in the subclass table. So 2 inserts instead of 1. Yes? Okay, the last strategy is what? Table per class. What does that mean?
Create new entity for each table.
For each subclass, yes. So I'll have 2 entities, one for part-time employee and one for full-time employee. Yes? Okay. It's good, normalized, not much nulls, columns, and so on. 1 inserts, 1 updates, and so on. What's the price? What's the disadvantage of table per class?
Everything will be repeated.
Only the columns will be repeated, yes. If there is some change, I need to change in both. So for example, if I add an extra column that is applied to both, then I have to add it in both tables. Yes? What else?
But all customers like to use 2 tables.
Yes.
Union.
The union, yes. If I want to know all the employees of the company, then I have to do 2 queries and union the results to get them. Yeah. So you see here, every strategy has its own advantages and disadvantages. But let me just quickly go through them. So in the single table strategy, as the name suggests, we collapse or we merge the common attributes with specific attributes and just create one table. That's the single table strategy. The problem, as I mentioned, you have some columns will be null. Join table strategy is basically your hierarchy and your ER diagram will look exactly the same. It's a literal translation. You do it as you see it. What you see, what you get. Same model in both sides. But the price you pay is very normalized, well designed, but you have problem with performance. You have 2 inserts, also for, if you want to get all the details of the employee, in this case, you have to join. And the last one is table per concrete class strategy. You will have 2 tables that correspond to the subclasses, and the common you repeat, the common attribute you repeat in these 2 tables. It works fine, except if you have a query that spans both. If you want to get both, then you have to query both and union the results. So for example, if you want to get all employees with the name starting with A, you have to do it in the part-time employee, do it for full-time employee, get the result, and do the union, and that will be the final result. So it's more costly in this scenario. So you will favor one over the other based on your application. You need to be familiar with each one. You need to be familiar with the advantages and disadvantages, and you pick up the one that is relevant. Okay. Here are the annotations. Take a look at this. Here is the annotation and how you do it. So for a single table strategy, you go to your superclass, and you add the annotation inheritance strategy single table, okay? And then you add a discriminator column. You must add a discriminator column. For example, and you give it a name. For example, employee type. Because if you put all in one table, how you can distinguish between full-time and part-time? You need an extra column. And you can say so by adding this annotation, discriminator column, and you put here the data type of that discriminator column. In this case, it's char, which will be 1 character. And then on the subclasses, you go there and put discriminator value. Yes? It will be F for full-time and P for part-time. And that's it. That's how it is done. Now, in the actual table, you will have the columns in the superclass, the columns in all subclasses, plus an extra column, which is the discriminator column. In our case, what is the discriminator column? The employee type. You define the discriminator column in the annotation of the superclass, and in subclasses, you say what is the discriminator value. Okay? So here, you define the column name and type, and in the subclasses, you define the discriminator value. So when you retrieve based on the value of the entity type, if it's F, you will get a full-time employee object. If it is P, you will get a part-time employee object. Yeah, it's very smart. Okay, you can see here we are bridging the gap or between the objects-oriented world and the database world in a very, very nice way using what? Annotations. Only annotations. Of course, once I put annotation, I will use Entity Manager to read and write. Okay. And the good thing here, you see, remember GPQL? You don't need to worry about which strategy did you use. You just write your query using the attributes of your classes. Then don't worry about how it will be done. The Entity Manager will generate the query or the queries needed to answer your GPQL query. Okay, here are the advantages and disadvantages. It's simple, fast, single update, single statement to insert and update. You have the problem you might face. You might have a wide table. If you have basically not a wide table. You will have a lot of null columns if you have a wide hierarchy, where the subclasses have a lot of unique attributes. Then you will have this problem. Okay, it's very good if you have small hierarchy, very few columns extra in subclasses. Then this will work very, very, very well. Okay, second one is joint strategy, as I explained. And joint strategy, this is how you annotate it. Okay, take a look at this. It looks very similar to a single table, except in here, the inheritance type. What did I put in the inheritance type? Joints. I need a discriminator column to differentiate between the two. And then here, all I did, still I have discriminator value, but I have an extra one here. If I wish, this is optional, this one. If I don't put it, what will be the name of the table? Full-time employee. But in some databases like Oracle, the name of the table will be all uppercase. It will be hard to read. So you better put something like this if you wish to customize the names to make it easier to read. So because there is no camel case in the database names, so you can put underscore between them, between the two words of the name. But the annotation is very, very super simple. Okay, so you will have a normalized database schema that is really mapped exactly to your hierarchy. But disadvantage for reading, you need to do join. For inserting and updating, you need to do it using two statements. One hitting the common table and one on the specific subclass table. Okay. Now the last one is the table per concrete class. Table per concrete class. So for table per concrete class, of course, this stuff is optional. You don't need to specify it. It's one annotation, super simple annotation. You just say inheritance. The strategy is table per class. Then it will create one table for each of the subclasses. And the common attributes are duplicated in these two subclasses, these two tables. Okay. So it's also in terms it is fast, because if you are dealing with let's say inserting full-time employee, you will insert in one table. Updating, it will update one table. The only problem, if you have a query that spans both classes, then you have a problem. You have to do union. You have to query one table at a time and then do the union. Okay, so to summarize, so JPA emerged from best practices from many existing ORM products. It took a lot of years, a lot of efforts to come up with such very elegant way of bridging the gap between the object-oriented world and the database world. And also it is standardized. There were many frameworks before doing it in slightly different ways, but they standardize it. And also usually standardization comes later after a lot of efforts. So they pick the best from different frameworks and put it in the standard. So it's simple and lightweight. It has a rich query language. It supports relationships and inheritance, and it works both in Java Standard Edition and Enterprise Edition, especially those of you familiar with the difference between the two. Okay, that's basically what JPA is. So I only covered one goal, which is the ORM. Yeah. So the final step, what I want to discuss now. So I created my entities. I mapped them to my tables. And then I used repositories. Remember repositories? Inside my repositories, I use the Entity Manager to read and write using the Entity Manager API. That's what I did. Now, when it comes to a real application, there's one more step. I need to expose, usually I need to expose my application to the web, because most of applications these days are either mobile applications or web applications, most of them. Okay, so the next step, once you do all of this, you need to provide a web API for the user interface or for other applications to make use of your database or to make use of your application functionality. This is my basically my customer. In here, in this customer application, I can get customers, I can get particular customer, I can get orders for particular customer, I can add, update, delete. This is the common operations. So let me just show you. I am making this whole application now accessible through the web. All of the efforts I have put in this is making it accessible through the web. So here, going through this API, I'm getting here the list of customers. Yeah. Now I can also get a particular customer, let's say one. Yeah. I get particular customer one and the orders of that customer. If I want to get the details of particular order, can you see here? I'm going from kind of generic collection and drilling down into the details. I can do here orders slash order number, let's say number 3. Yeah, I get that order. With small efforts, I'm doing all of this. I'm basically exposing that application through the web. And the reason I'm exposing it this way, so I can dress it up with multiple interfaces if I wish. And I can also make this functionality can be consumed in another application. For example, you have a list of students exposed by banner, and then Blackboard can come in and get that list, yeah, programmatically. That's what the reason we have this web API. Not only for retrieving or getting, I can also do this web API for adding, updating, and deleting. Okay, so let me show you. Because in here, for adding, updating, and deleting, if I just use the normal browser, I cannot do this. I need to provide a user interface to do this. But luckily, there are tools out there that help me quickly test my web API without creating a user interface. And one of such tools, very famous tool, it's called Postman. Okay, so let me show you quickly here. And then I'll explain to you how I did this. So I want you to get the full picture, although this is getting a little bit out of the scope, but it is important to see how really database fits in the whole application, end-to-end application. And without having a meaningful application without an interface, but still very meaningful. Okay, so I can do the same here, get. And the reason why I'm getting JSON, I can also ask it to give me, I don't want to get JSON. I want to get an old-fashioned data format, which is XML. I can get my list of customers in XML format. Yeah. Also, I can get particular customer. Here it is, customer 3, not found. Let's say customer 2. Yes, it is found here. Now, I can also add a customer. So here is where this tool excels. I can really now add a new customer without having an interface, just by having an object in JSON. Here, all I do, open my curly brace and put the name and value pair of my object that I want to insert. So let's say if this object has first name, last name, date of birth, email, password, whatever it might be, you can very nicely test it by putting a JSON object here. And then you say, go ahead, post this. Don't use get, use post. And post this object to this location. And in there, this will take this object and push it to the database. So if I do here send, you see here everything went okay, 201 created, and I get successfully created object. I can verify this by going back to this and put in here 3 and passing this. You can see here 3, they have no order. Now take a look at this. If I go to, I can also delete if I wish. You see here delete. I want to delete customer 1. Send. It will fail. Why it is failing? Because it has orders. I cannot deleting orders. I can try deleting orders. So let me get this is customer 1. Yes, customer 1. How many orders they have? 2. Order ID 2 and order ID 3. So let's go for delete. And then go here customer /1/orders/1. Go ahead and delete it successfully. Order 1 is gone. Order 2, order 3, yes? Order 3 is gone. In modern web applications, this is very common architecture, how modern applications are developed. So you have some kind of, typically you will have some database that will manage your data, and you will have some logic that interacts with this data, with this database. Typically, those are your repository classes. And then this logic that is implemented here, you expose it to the outside world as a web API. And then you can build any front end as you wish. You can have a mobile app, or a web application that they will all share the same web API. And once you do this web API, especially as developer, there are some developers, they call themselves backend developers. This is where they stop. They don't care how the front end will work. Some others, they just use the front end. They develop the user interface. And what's the glue between the two is the web API. That's how you glue the two together. Okay. So what web API allows you to do, it allows you to access your logic, which means you will also access your database through the web. Anywhere from the web you can access it. So to achieve this, in any language, you will have some kind of libraries that come with the language to help you build such web API. In Java, for example, for programming web API in Java, we use set of libraries known as JAX-RS, Java extensions for REST services. So web API, you will also hear the term REST services. Those are equivalent terms. REST services they mean the same thing. Remember, in Java, there is always this story of standard and multiple implementations. So JAX-RS is a standard. When I say standard, like major companies, they get together and define what are the classes needed, the annotations needed to create a web API. Yeah. Now, one of the implementations, there are many implementations of JAX-RS. One implementation that's quite widely used is called Jersey. Okay, and this will allow you to create a web API using Java. Now, with this very super small introduction, I want to show you concretely. First of all, I want to show you one of the important skills that if you want to do web API development, you need to learn how to design the URL. Yes, the URL is very important. You need to know how to design them. And the way you design them, you basically go from collections, from a big collection. It's like a kind of navigating a file system. You go from C drive, then you go to folders, and from folders you go to subfolders, and from subfolders you might end up with files. Similar. So for example, here you might, in an order management application, you might have 3 top-level resources or 3 top-level services. So orders, this will give you all orders. You can also filter them by ID, where you can get a particular order by ID. Same thing for products, and same thing for customers. You might also go for customer ID and /orders to get the orders of that particular customer. And you can go / ID of specific order. So that's how we typically design it. We drill down from general collection to specific ones. Okay. Now, once we design this URLs, then we interact with them. We interact with them using HTTP. So HTTP is a communication protocol driving the web. Very super simple protocol. It has a couple of request verbs that you remember. The web is a client-server architecture. There's a client, typically a browser, and there is the server, a web server, typically hosted in some kind of somewhere on the internet. So if you want to request something from the server, you need to use a verb, and these verbs are well known. There is a get verb. If you want to read, if you want to get a particular books, for example, in Amazon, you can say get /books. We'll give you all the books. So /books/ a particular ISBN will give you that particular book having that ISBN. You can also create a new book by sending a post request. So you do post, you put a URL, and you put a message, which is the JSON I showed you, a JSON string, and the system will receive that JSON and create a new book. Put is for replacing, and delete is for deleting. Okay, so to summarize, in very, very high level, the web is client-server architecture. The client sends requests in a standard format, and these requests basically have a verb followed by URL, a verb URL. And this verb is standardized. Get for retrieving, post for adding, put for updating, delete for removing. Yeah, that's all it is. And then when you are getting something from the web, this thing that you get, we call it a resource. A resource is a very generic name. And this resource can have different formats. You can have HTML formats, JSON formats, XML format. So those of you not familiar with these things, here is the XML, how the XML looks like. We have a tags, and then we open the tag, put the value, close the tag. Open the tag, put the value, close the tag. This is one format, or you can have the same information, more lightweight, JSON. I already discussed this before, yes? So this is getting out of fashion, and this is more the standard way of communicating. So when you are using mobile application, most likely your mobile application is sending JSON, receiving JSON. Your modern web application, that's doing the same. Sending JSON, receiving JSON. And modern web applications, the user interface is built on the client side. So the communication between the client and the server is basically using JSON. Yeah. Okay. Now, the final thing I want to show you how do we build such web API. Very simple. The way we build them, we go to a class and we associate a class with a particular URL. Okay? Or more precisely, let me show you a concrete example. Maybe it's easier. Here is my customer service. You see from this URL, if I go to /customers, what should I get? All customers. In this case, in XML format, I can get them in JSON format. So what I have here, let me just remove this. That's all I'm doing here. All I'm doing, if somebody comes to /API/customers, please using a get verb. Remember the HTTP verb, we have get, post, put, delete. If they are coming to /API/customers using a get verb, they will land here in this method will handle that request. And this method is doing what? Is doing completely nothing by itself. It's all it's doing, delegating this to the repository, saying to the repository, please go ahead and get me all customers. Now, there is this little annotation here that I'm saying, when you send back the result to the customer, please send it either as JSON or XML, as they like. Now, the user of my service, they can say, using this HTTP, well-known standard HTTP header, they can say, please give me the data in JSON format by saying accept application/JSON. So if I do this, I will get my customers in JSON because I put here, because in here I put accept. I accept from the server. Accept means this is my preferred format. Or if I wish, I could say XML. Send. And I get it in XML. Okay? So it's very super simple. All it is annotation based. I come to my method and say to it, okay, if somebody comes to this particular URL with a get verb, please call this method and don't return for them list of customers. They will not know what this means because this is Java world. On the web world, there's no Java or there's no Java objects or anything. You need to serialize it, or you need to transform this list of customers to either XML format or JSON format. Okay? and this is done automatically for you. All you do here produces XML or JSON. Let me show you. If I want to get for a particular customer, what do I do? Customer / the customer ID. Okay, and here is this is the details of one particular customer. Who is the lucky method that will handle this? This is the one, because I sent this request using a get verb, and this is the URL I send it to. This part of the URL API / customers will land me in this class. This class will handle /API / customer, and this /ID, the last part of the URL /1, that one is a parameter. So I pick it up. I pick up that one and basically go to my repository, retrieve the customer, and then basically return it. If I find it, I will return it. Otherwise, I will return not found. If I try to, for example, put here 10, I get not found. Yeah, and so on. Same little. If I want just to get the orders, this is the one that will handle the orders. Okay. If I go to /customer /orders, I get the summary of orders. So that's basically how it works. It's not limited to get. I can use it for post. If somebody wants to add a customer, they will do post, and at the end of the day, this is what I will do. Go to the repository and add it. Same thing for put, for updates, same thing for delete, and so on. So this API is nothing but a class that has methods. You already know those skills. And I add some annotations to make these methods accessible through the web. And that class becomes a web API, or also known as a REST service. That's all to it. Once I do this, I have basically very nice architecture. Once I do this, I have a very nice architecture that I can now make use of this in any application, whether web, mobile, from other application to application communication, all of this can be done. Yeah.
Victor,
Yes. Yes, please.
you are working on the same connection of the local host of the database, or there is another connection? The port and the
No. Okay. Good question. So basically, look, this is the database is a separate component in my architecture. Yes. And it could be working, it could be running either on the same host or in another host, regardless whether it's same or outside my host in another node on the network, it will be listening at a particular port. Yeah. Now, my web API will also be hosted and listening on another port, different port. Okay. So once I create all the services that I need to host them on a web server. Okay. Now with modern development now, this is just I discovered only I think yesterday. Before we used to use some heavy web application servers like Glassfish or WebLogic or but the trend now is to use a very lightweight servers. One of them called Hibernate. This is a newly released by Oracle, became open source. It's a trend. Whenever they get annoyed with some library or some tool or some engine they have, they just push it to open source. Anyway, it's open source, and it has very super light web server. And it can run in a normal Java program. So let me show you how this web server is hosted. And this is the last thing. I have to let you go. Here it is. It is the main. Remember a main method in any Java program? Main method in any Java program. All I'm doing here, I'm saying, build a server for me, configure it. This is this is the host name, this is the port, build it for me and start it. In few lines, I am basically self-hosting my own application on a simple Java program. I don't need to have a full-fledged server deploying it there. I can really host it myself. Yeah, that. Not only for development of course, but even for production. You can do this. This is the trend. And that's it. This is how I host it. And basically, this is how I make this web. This is how I make it aware of my classes. All I do, sorry, here it is. Yes, it's a little bit kind of cryptic the way they did it. This is how I make my server aware of my services. It's just this cryptic. I didn't even have a chance to have a look at it, what it means. I just put here the class names of my services, and the server will pick them up and expose them to the web. Yeah, it's very simple. In the old days, you need to compile this, package it, and then push it to some kind of server. In here, no, you are hosting your own server and deploying your application on that server in few lines in the main method. Yeah, and those few lines don't change. You don't need to bother with them. In fact, I copied these 2 lines from the demos that came with this simple web server, and I just added. They had this hello world service, and I added my own customer service, and that's it. They are listening on 2 different ports. This one is listening on. They are listening on hello port. Sorry, not ports. Different URLs. This is the hello. This is their example. And this is my examples, API/customers.
And we should run the database before running the service.
Yes, database is here. I'm using Derby database, so let me stop it here. This is Derby. I downloaded it, installed it, and then I go to these cd Derby cd bin, and I say here start network server. It will start listening on port 1527, I think. That's it, 1527. So my web API, which port it's listening on to? 9090. That's the concept of a port. I might have multiple applications listening to incoming requests, and the operating system, when the request comes, it will route it to the correct application based on the port number. Yeah. And by the way, these components could be living on different nodes on the network. In fact, it could be totally removed. Remote. For example, database, I can host the database on the cloud and then access it from my app, no problem.